All right, day three, I think. Yeah, day three. Um, so yesterday went well, but I probably should have made the run function uh, not destroy the program and have it return a modified version of the program. That would have been a smarter design. So if we have a similar problem today, I will try and do it uh, that way. So, and I think I have this all set up correctly. Um, maybe I'll zoom in one more. That will make it easier to read. Okay, so let's see what the problem says. Crossed wires. Gravity system was successful. You're well on the way back to the Venus refueling station. During the rush back on Earth, the fuel management system wasn't completely installed. That's next. Jumble of wires. So like two wires are connected to a central port and extend outward on a grid. You taste the pass two wire takes the central port. One wire per line of text. Your puzzle input. The wires twist and turn, but the two wires occasionally cross paths fits the circuit. You need to find the intersection point closest to the central port. Because the wires are on a grid, use the Manhattan distance for this measurement. While the wires do technically cross right at the central part where they both start, this point does not count, nor does a wire count as crossing with itself. For example, if the first wire's path is R8, U5, L5, D3, then starting from the central port O, it goes right 8, up 5, left 5, and finally down 3. And if the second wire's path is this, it goes up 7, right 6, down 4, and left 4. These wires cross at two locations, but the lower left one is closer to the central port. Its distance is 3 plus 3 equals 6. Here are a few more examples. R75, D30, R83, U83. Distance 159. Okay, so let's see how big this input is. Okay, so this looks all right. So I think what I want to do is I want to keep track of all the locations the wire visits. And so from typing import named tuple, and I'll just do class xy named tuple x and y int. So I will use this. I'm changing my method to the end to keep track of points, just so I can like hash them and stuff. And now what I want to do is, so if I start here and I go R8, 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then that. And so I basically want to keep track of all the locations, which, seems a little bit excessive for these because there's like 1,000 times 50, so it's like 50,000 locations. But that's fine. 50,000 locations isn't that many. And so let me get a path like this. And so let's get a set, and let's do locations, and let's take, what do we call this, a path, which is a string, and it's going to return a set of xy's, and so that's what that looks like. And so let's say loc equals 0, 0, and visited equals set. And so now what I want to do is I want to say for let's call that line in path.split on commas. And so that line is going to be like R8. So let's say dir equals line 0, distance equals line 1. I won't call it dir because that's a built-in. That's why it's colored like this. Direction that, and rather than actually this, I'm just going to do x equals y equals 0. That will be easier. So for I in range distance, if direction equals up, then y plus equals 1, elif direction equals down, y minus equals 1, elif direction equals r, x plus equals 1, elif direction equals l, x minus equals, it doesn't really matter like how I call them because we're just going to, as long as we're consistent about it, and as long as up and down. And then otherwise, raise, runtime, error, bad direction. This is like more defensive than I probably need to be for this problem, but that's fine. And then what I want to do now is I want to do visited dot add what do I call it? XY, x comma y. And so, let me just try this out. Run day3.py and locations of this, because I did not return the visited. Let's run it again and then do the locations. And so I get 102030. And there should be a 40506, whatever, because it's doing a set of them. So that's okay. And now closest intersection. So def closest intersection. Path 1 is a string, path 2 is a string, and that's going to return an xy. And what is the Manhattan distance? That's fine. So what I want is locations 1 equals locations of path 1, locations 2 equals locations. Let me do this, just it'll be easier to test. So either all intersections to set x, y, locations path 2, and return locations 1 dot intersection locations 2. Okay, and so like in this example, and let me just do this and say, path 1 is this guy, and path 2 is this guy, and print all intersections of path 1 and path 2. So now let's just run this and see what happens. And I forgot the colon. So let's do that, and say these intersect at 3, 3, and at 6, 5. So that's 3, 3, and that's 6, 5. So that's good. And then, let's say def closest intersection path 1 string, path 2 string, goes to int. Let's say AI equals all intersections path 1, path 2, and closest equals min I for I in all intersections, if I is not equal to 0, 0, just to make sure that, well, I'm actually not going to do that. I'll just say return min AI key equals sum. And because sum is going to work out to be the distance, right? Because Manhattan distance is just the sum of two components. So assert that, closest intersection or, so let's get these two and make sure that they work. Assert closest intersection of this guy and this guy is 159. And then finally assert that the closest intersection of this guy and this guy is 135. And, I'm worried that again, this might be too slow, but let's run it. And I got an assertion error, and the assertion error is that, so let's right, because I actually need to, let me do this, sum I for I and AI, so that, so I was using the sum to find the closest one, but then I was returning the closest one, not, okay, so this one doesn't work either. So let's see why that is. I wonder if it's going to run into the 0 problem that I had. Okay, let's copy this. And 146, and this one says 159. So let's think about why that would be. Well, it's hard to say why that would be. So let's look at because because I don't want to do the sum. So okay, I see the problem. Def Manhattan distance xy xy returns an int. I didn't take the absolute values, which was the problem. So return abs xy dot x plus abs xy dot y. So min Manhattan distance I for I and AI. So let's try it again and see if it works today. Okay, so good. So now it works. So the issue was that I was summing them, but they can be negative, and even if they're negative, I want to count that as a distance. So so again, I'm just going to copy and paste this because I'm lazy and it's not that long. So now what I'm going to do is I'm going to say path 1 equals this guy, and path 2 equals this guy. And print closest intersection, path 1, path 2. Okay, and hopefully this doesn't, these are going to be pretty big sets. So let's see. But it says 768, so let's try 768 and see what that says. That is the right answer. Good. Okay, so that was inefficient to generate every single place that they go, but it worked. So let's go to part 2. It turns out you actually need to minimize signal delay. Do this, calculate the number of steps each wire takes to reach each intersection. Choose the intersection where the sum of both wires' steps is lowest. If a wire visits the position on the grid multiple times, use the step sum from the first time it visits that position, calculating the total value of a specific intersection. The number of steps a wire takes is the total number of grid squares the wire has to enter to get to that location, including the intersection being considered. Again, consider the example from above. in the above example, the intersection closest control point is reached after this many steps and this many steps for a total. From the top right, the first wire takes only. Here are the best steps. So the fewest combined steps the wires must take to reach the intersection. Okay, so now what we want to do is we want to, I'm actually, I don't know what I did there. I don't start the bugs. Okay. So I'm going to make another one because I'm going to basically destroy this day032.py. And I'm going to make the following change is that I am going to, instead of maintaining a set now, I'm going to maintain a dictionary of how many steps did it take for me to get there. And so I'm just going to go through and change everything, but I'm doing it in a different file to keep my, so it's going to be a dict from x, y to end, and it's going to, you know, return the minimum steps to each location. Okay, and so now we're going to do num steps as well, and visited is going to be an empty dictionary now. Okay, and so now what I'm going to do is I'm going to say, you know, location equals x, y, x, y. If location not in visited, visited location equals num steps, and then I'm going to increment, and then I'm actually going to do num steps plus equals 1 here. So now I've got this dictionary, and I'm going through, and the reason I check for loc not visited is because it said the first time it visits that position. So I want to, you know, just find the first time. Okay, and so now, again, I'll do this, but now these are dictionaries. So I'm actually going to make a set out of them, and make a set out of them as well. So all intersections is still going to do that. And then what I'm going to do, actually, I'm going to wipe that out, and I'm going to wipe that out too. And so what I'm going to say is I'm going to say distances 1 equals locations of path 1, distances 2 equals locations of path 2, and then I'll say that intersections equals set of distances 1, and that will just operate on the keys, dot intersection of set distances 2. So this is just going to find what are the keys that are in common in both of them. And so now what I want to do is I want to return the minimum of, so I want to say distances 1 loc plus distances 2 loc for loc in intersections. So for each intersection, I'm just going to look up how long did it take me to get there in the first path and how long it took me to get there in the second path. And now let's see if it gave me any test cases. So it said this should be 30. And then the second one should be 610, and then 410. So let me, and let me just comment this out now. And now let's run this day032.py, and those tests pass too. So that makes me think that I'm doing the right thing there. So now let's just run it, and it says 8684. So let's copy that and go over here and do 8684. And that's the right answer. 1 gold star closer to rescuing Santa. Got ranked 233 on this star's leaderboard. So 233 is not enough to be in the top 100. So I did not make it in the top 100. But, it's, I feel like did a pretty good job. I'm not unhappy with this. So yeah, so that worked. And as always, thanks for watching, and I'll see you tomorrow.